Hey, welcome to EV Medics. My name is Christian, and in this video I'd like to walk you through my process on how to identify the location of a high voltage insulation fault in this 2014 Tesla Model S battery pack. So let's get into it. Here are the typical codes you're gonna see on the screen in service mode. BMS W142 is isolation degradation. BMS W123 internal isolation, and the most important one, BMS F123 internal isolation. So I guess the reason you're looking up this video is because you're having also issues with exactly those messages, and that is typically caused by an internal fault in the battery pack. In this case here, it was caused by water ingress into the pyrofuse of the vehicle, which by itself is caused by very poor design by Tesla. In general, I love this car, but the way they designed the windshield and the plastic trim below it kind of leads to this fault quite often, actually. And that's the reason I had to take the battery out and open the pyrofuse housing and fix the internal insulation issue. All right, guys, we got the battery out of the car. We opened it up, and now we have access to the back where our contactors are located. And what we're going to do next is to measure the voltages between the contactors and the housing of the battery. And that voltage will tell us, based on the chart I'm going to share with you later, where and what area of the battery between those 16 modules we can expect the insulation fault. It's a pretty easy and simple way to do that. As you might know, the BMS is doing nothing but this. It's constantly measuring the voltages between both terminals, plus and minus, positive and negative, against the housing, and based on that value it's able to calculate our resistance value. And as soon as it's below 1 mega ohm, it's flagging the battery pack, and the car shuts down, and we are in this situation sitting in front of an open battery. Our contactors are located here in the back of the battery. Driver's side, this contactor here is the negative contactor. The inside is with the full potential of the battery connected. And this side is the switch side that goes over to the outlet over here. So when there's no power on this contactor, this outlet is dead, and that goes into your car, obviously. The inside is the positive contactor. Also here on this side with the white bus bar connected is the full potential. So if you short out these two terminals here, you would have a full short on the complete battery pack, which is not advisable. Whenever you work on that, wear your safety gear. Okay, voltmeter switch to 600 volts DC. Okay, I'm now going to, one probe is in contact with the housing, and the other probe I'm going to contact the terminal. And we're getting 310 volts on the negative side. Gonna write this down. And now the same over here on the positive side. We get 44 volts, 310 and 44. Okay, we measured 310 volts at the negative contactor. And on the positive contactor we had 44 volts. And we're going to divide these now with the voltage of one module. Then again, we have 16 modules in this car, and the voltage of each was 22 volts. So this divided by 22 is about 14. 14 point something, doesn't matter. And 44 divided by 22 is, well, you guessed it, 2. And now you can see already if we combine these two figures, we get 16. And that's exactly the amount of the total modules we have in a 85 kilowatt hour battery pack. Right? Now with that, you can already tell where this is going. We can count, basically, based on the voltage, we can count our way through the battery, and we know at what location, at what module our fault is. So in this case, it's between 14 on the negative side, counted up, and 2 at the positive terminal. But the problem, of course, is we don't know how the modules are interconnected in this battery pack, and therefore I made this diagram here. So that shows us how they are linked together. This here is an image, I'm sure you have seen that before. It's floating around in the internet. It's basically showing us the how the modules are numbered. This is the front of the vehicle. So module number 1 is located in the back, driver's side, and then it's counting up to the front of the vehicle. Number 7 is the last one of the flat section, and then number 8 is at the bottom of the penthouse, number 9 on top, and then it counts its way back. But this is not at all how they are interconnected. So actually, so this here is module 16, this is number 1, number 2, number 3, number 4, number 5, so that's the numbering we have over here, and the same going back. But then when you see how they're electrically connected is the positive contactor. So yeah, I had this wrong. So this here is the negative contactor, and this is positive. So the negative contactor is connected to the negative side of module 16, the last one in the chain. And then it winds over to module number 1, this one here. And obviously this is a series connection, so each module is they're in a chain. Plus is connected to minus, and then this plus is connected to minus of number 15. So number 1 winds over to 15, positive of 15 winds over to number 2 on the negatives, and so on. So this is how it zigzags its way forward to the penthouse. Okay, so now again we measured 310 here on the negative contactor, and we measured 44 volts on the positive. Yeah, and as we calculated here, 44 divided by 22 is 2 modules. We can now count our way up. So we go from the contactor 2 modules down. First one is number 9, then number 8, and right here is the pyro fuse. We already knew that our fault is the pyro fuse, so this is basically just reverse engineering it. So we had our 20 and our 44 volts here, right at the pyro fuse. And if we do the same model now with the 310, divided by 22 is 14. So we count 14 modules and should again end up at the pyro fuse. And obviously we do that. I mean, it's pretty clear looking at the numbers already. So we start here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. And boom, we are at the pyro fuse. And that's how we can trace this back with the simple way to calculate. So the negative bus bar here for the negative contactor goes through the middle of the battery pack right here. And then it goes over to the contactors here, roughly. So it connects to number 9 somewhere here. And again, negative comes from here. Okay, with measuring the voltages, we could verify that our isolation fault is indeed located at in the pyrofuse housing. And now what I'm gonna do is I'm gonna take the pyrofuse out and measure the voltages again one more time, and they should decline. The voltages should decline to almost 0 or close to that, and then we know we are good. Okay, pyrofuse is out, and as expected, soaking wet, full of water. That's a positive indicator. Plus we have also water sitting in this tray here. And yeah, there are bolts below submerged in the water. Obviously, I don't want to touch this right now. But yeah, that is what's causing the contact to ground, water being in contact with the pyrofuse. So now we're gonna measure the voltages one more time. Back to the contactors. Oh, we still have moisture on the wall of the housing. Yeah, that's an indication that the moisture creeped up the wall of the pyrofuse housing itself. So I need to completely dry this out before continuing. This side has only 12 volts now. This one still 240, so it lost about 60 volts. We got the pyrofuse dried out, and now we're gonna measure voltage again. Start with negative. Ooh, 18 volts, 14 even. It's still going down. Yeah, because I guess the walls still have some moisture on it. And positive side 37. Just as a reminder, yeah, this side was 40 before, and this side was 310 before, and now it's even lower. Yeah, it's still 15, 16 volts. Now with the pyrofuse out of the way, I want to test one more thing. I want to purposely install an insulation fault somewhere here in the battery, and then use my chart here to first calculate the voltages that I should see on the contactors in the back. So for that, I'm gonna use a 100 kilo ohm resistor that I'm gonna put onto module 13 against the housing of the battery. Okay, got the resistor connected to housing on the negative terminal of battery number 13. 1, 2, 3, 4, 5, 6. 6 times 22 volts per module on the negative contactor. And so 6 times 22, forgive my ignorance, I have to calculate that. 6 times 132 volts on the negative contactor, and 13, so we should see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 22, 222 on the positive contactor, 132 on the negative, and 222 on the positive. Okay, voltmeter hooked up. So again, we said 132 should be the volts at the negative contactor. Let's see. Wow, spot on. 132. And 222 on the positive. Just this one here. 218, close enough. So yeah, that verifies that this system works. Okay guys, so with that I think I've proven that this concept works and it's reliable. It's a good method to identify where the insulation fault is located. And with that I wrap up the video. Hope to see you next time. Goodbye. So I actually disassembled the pyro fuse just to see what happened to it internally with all the water seeping in. And sure enough,